Hey there, CIS 276. In this challenge problem, we will be working with functions and we will be working with arrays. Now, arrays here is the bigger takeaway. This is chapter 7, so that's the focus from the chapter. But I know, because of its relative, I'll call it newness, that a lot of students want to shy away from the idea of the array. So before we get into the description for this, let me just remind you of the following couple of things here. Number one, you have already built a lot of this project out in your previous challenge problems. So I still fully encourage you to go back and reuse the menu structures from some of your previous challenge problems. I encourage you to go out and reuse from the chapter 6 challenge problems, the structures of your functions, the structures of your function calls to menu structures, things like that. What I really want to remind you and encourage you again here is you are building a code platform to use on other projects. So use that code platform. You do not have to start this or any future, nudge, nudge, wink, wink. You do not have to start this or any future challenge problem from the ground up. You have been building those challenge problems towards this, the radio challenge. You will build this radio challenge towards the final. It's the vector challenge. So just remember that as we're going through here with the description, that you should be keeping an eye towards your previous developments to see what it is that you can cannibalize from those and deploy here. So first and foremost, as we scroll down a little bit here so I can read that, we take for granted, and we really do take for granted, all the places that we see arrays on a daily basis. So when we go to a grocery store, we are seeing arrays of fruits, of, dairy products, of frozen foods, etc. And life really does tend to sort itself by homogeneous groups. The array is everywhere. And I, for one, know that I am extremely familiar with the one sort of array proposition that I see all the time, every day. And that's as I aimlessly scan through my radio presets, as I aimlessly scan through the FM and AM dials in order to find anything to listen to on my 90-minute drive to work and my 90-minute drive back from work. So you are going to use arrays and functions to create a radio interface. So those arrays should go as follows. So this is for 10 points. You will have a minimum of 4 arrays. Now you can choose to do this differently, but the points are structured 2.5 points apiece for each of the following 4 arrays: an FM1, an FM2, an AM, and either a CD or an MP3 folder or whatever else, XM satellite radio, whatever it is that you would like to include for your 4th array. Each one of your radio clusters will include 6 radio elements. So there I am telling you how many elements your array minimally will include. Just to create a little bit of difference and to further prove the point that if you are using an enhanced for, or if you are using a while loop correctly, it will not matter how many arrays, or how many elements rather, are in your array. It will loop correctly based on the length of your array. So to make things different, just to show, the CD or MP3 or XM, whatever your 4th array, will hold 10 elements as opposed to 6. So that is the first 10 out of the 70 points. Use named constants to control the sizes of your arrays and your looping mechanisms. I know one of the things that I get the most questions about is why would I use an additional, essentially one line of text, of code rather, to be able to say what the constant size of my array will be. And because, again, an array is immutable. Once we declare the size of the array, it cannot change. So we may as well use an immutable constant for that as well. So I am forcing the issue here so that you can see how nice and tidy it is that makes your looping mechanisms. But just as a foreshadowing, I will not make that same requirement. It is not a request. It is a requirement here. And that is a 10-point requirement. But in the vector challenge for 2 sessions from now, I will not make that same requirement, just so that you are aware. But because technically speaking, you won't be able to size those vectors the same way, or you don't need to at any rate. So, named constants for 10 points. Use formatted output to properly display the radio control and radio outputs, 20 points. You'll notice we're asking a lot here of this is our user interaction. By now, your user interactions have gotten better with each one of your subsequent challenge problems. So something I know I've been seeing a lot of, which is good. I've been seeing a lot of since the chapter 4 challenges is, color options in your display outputs. That's fantastic. Some things that we've seen a lot of, through the vending machine and the gas station and the game and things of that nature challenges are, a really good digital analog of the physical layout of the device it is that you are trying to replicate. And those kinds of concerns really are good for the user. The closer it is that your digital representation of a physical car radio. So mine is just a Camry. It is the cheapest car radio that the law will allow. But still, the closer it is, you do not have to make a Camry's radio, by the way. That will be maybe a little soul crushing, I would expect. So you do not have to do that. But, whatever the layout it is that you create, that I can interact with digitally as the user, that pays dividends because I have familiarity and an expectation when I am dealing with a car radio. The closer it is that you can recreate that familiarity, the closer it is that you can recreate that expectation set, the easier it is for a brand new user to be able to interact with your system and to interact well with your system. So that's 20 points to clearly show the driver what is on the radio station. So what you do to make that display work is generally up to you here. Clearly indicates to the driver how to interact. What I will tell you here is in previous challenge problems, I have often, essentially what I do is, I have your Replit window open here in front of me. So here's your files, here's your code, here's your output. What I'll do is run it in that split style window so that I can read through your code to see what your expectations are for how it is that I interact with you. And by now, many of you will have seen, comments in your previous submissions that indicate things like, you have to tell me how it is that I can get back to the main menu. You have to tell me how it is that I make these selections. Here, I am making that a big point value so that we can really start hammering this down. When you have an expectation for the user to be able to interact with your product, you have to communicate those expectations clearly. So that is another set of 10 points there. Excuse me. So that is formatted output for 20 points. Repaints the display so the driver can see what's going on. You can use the system-dependent call for this. So remember, and many of you have, chosen one way or the other, the system-independent, a string of 50 new line characters, which has the added disadvantage of painting your your display at the bottom of the screen, which I know for some of you has been a point of contention. Or you can simply use system and then in parens clear. Clear would be in the double quotes and all lowercase. Clear, that is how to do a system clear here inside of Replit. Whichever one of the two of those it is that you wish to do is perfectly fine by me. But what we want is an uncluttered display window for the user to interact with. So it's a 5-point, it's a small piece of contention here. But what I do think it does is it will make this challenge problem and your next challenge problem look better if we force you to clear the screen, which is something that roughly half of you have been doing. But for the other half, I think it will be a nice revelation. 20 points here for functions. Now, just as a breadcrumb trail here, I will tell you, you'll notice that our functions requirement is way, way down here in the description. That is not necessarily an accident. Think about what you want to do for the layout of your program first, and then build your function calls around it. I know I've been working with a host of you guys, and I've worked on this project with students in the past. And what I'll tell you is when a student sits down and just starts typing and I'll call it unnaturally says, this is going to be a function, this is going to be a function, and you haven't thought your way through it, it extends the amount of time it takes you to work your way through the project. It's just not necessarily functional programming, functional thinking with these method designs like this isn't necessarily how your problem solving is going to be based just yet. Now, when we get through 277 in another semester or two with almost all of you, yeah, I mean, maybe you'll start to think more programmatically that way. But it's not something that necessarily you'll think of right away. So it's just a suggestion. It is not, there's no way to prove this. There's no points values associated with when it is that you create your functions. I'm just making a requirement for functions here. But let me suggest to you that when you have thought your way through, how will I interact? How will I loop through my mechanisms? Things of that nature. What do I want the display to look like? Then it starts to make more sense to build these functions in. Just a suggestion. So allow the user to change the radio station. Certainly, that's one of them. And another for saving radio stations into your station list. So you will be working with passing arrays to functions. Quick note here in an already long video, I know, and I'm sorry. There is immediately underneath, if you are looking structurally down the session, the module rather, in Eagle, you will see help with passing arrays to functions. Please, please, please go take a look there. It is a simple design change where instead of pass by value, we would pass by reference, the actual address of your array as it is in storage. That will help. I know it's one of the big problems many of you are going to face here in the beginning. So please, 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 there is a video, there is code sample there. It will help you figure out how to pass those arrays to functions more properly. So I only have 2 listed functions here for you. I suggest it's probably easier to have more functions. I'm not going to make it a requirement, but if you think about things like your menu, that's a function you can borrow wholesale from your chapter 6 end of chapter challenge and get to work here. Something to ponder. Looping mechanisms for 5 points. What I'm telling you is this has to loop. So as long as the driver keeps the car running, I want this to loop. So if at any point I am interacting with your program and it simply kicks me out, that is going to break the rules of these 5 points. Figure what kind of while or what kind of do while loop. You'll notice I'm not giving you the option for a 4 here because it does not make a particularly grand sense. A do or a do while loop, or a while rather, or a do while loop, so that you can get this looping done. So you have the week that follows this to get this done. Please remember two things to help keep you moving here. Number one, to go back and reuse code from previous examples. And number two, for passing arrays to functions, check the helper video that follows immediately after the assignment description here. So you can message me as always with any questions, and good luck 276.